All right, Amanda, if you want to stop sharing, we'll go to the next slide. All right, so without further ado, I'm going to hand it over to Stephen Quarles. Steve is a University of California Cooperative Extension Advisor Emeritus and the retired Chief Scientist for Wildfire and Durability at the Insurance Institute for Business and Home Safety Research Center. Steve is a wealth of knowledge, and we're really lucky to have him here to help us along. He has also been our key expert in this home retrofit guide that we're working on. So I'm going to pass it on over to Steve now.
Thank you so much. I'm going to share my screen. So thank you all for attending. And as you'll hopefully find out, this is going to be a pretty interactive session. So a lot of time for questions. We want to just talk about home and buildings and how they're vulnerable to wildfire and things that can be done to reduce that vulnerability. So let me advance this thing. Okay, so I just have a few sort of introductory comments about how homes and buildings are threatened by wildland fire. For those of you that know a lot, you probably already know this. For those of you that are new, this will be a good summary or a good introduction. There are three basic exposures: wind-blown embers, radiant heat, and direct flame contact. We really want to avoid direct flame contact. So a lot of what we do will be intended for that purpose. But we'll also talk a lot about embers tonight, since they are so important to home ignition scenarios. Post-fire surveys have shown that between 60 up to 90% of home ignitions result from ember exposures. Okay. So we know that embers are important because of things we've seen in post-fire assessments, and this is just one example. Here we have, this is the 2007 Angora fire, South Lake Tahoe. Home destroyed, but a lot of green vegetation around it. So we know it wasn't the wildfire front that burned up to the home and ignited it. It was the embers that flew over a lot of land area and landed on, in, or near the home, ignited it, leaving the intervening vegetation sort of undamaged. So this is a good visual of why embers are so important. They're important because of what they do directly and what they do indirectly. As Carly indicated, I'm retired from the Insurance Institute for Business and Home Safety, and I worked for 8 years or so at the research center in Richburg, South Carolina. So a lot of what I learned is from that experience, and a lot of my visuals are from them and are from there. And this is one example. So the upper left-hand picture is from the research center, from the test chamber. It's a large wind tunnel facility. You can put full-size buildings in it. IBHS conducts research on the built environment, to better understand the impact of natural hazards that have a wind component to it. So it's a large wind tunnel, hurricane, hail, wind-driven rain, and wildfire. And when we're doing wildfire research in the chamber, one of the things we can do is set up these ember generators that blow embers to the wind stream of the wind tunnel and project them at the building. With this kind of technology, we could definitely understand better the vulnerabilities of buildings to ember exposures, and almost equally importantly, evaluate mitigation strategies from those ember exposures. So this upper left-hand picture sort of shows how we went about doing the research from a wildland fire perspective. The direct and indirect ember ignition scenarios are shown in the other two pictures. So the center, the lower picture, excuse me. The lower picture shows a fence and embers igniting that fence without the help of any other debris or any other thing. It was just the material of the object itself. This is called what I call a direct ember ignition. But I think more importantly are these indirect ignition scenarios where embers ignite something next to the home, on the home, near the home. These indirect ember ignition scenarios ultimately result in flames touching the home or radiant heat exposure to the home. For example, if a wood pile near the home is ignited, that would be a radiant heat exposure to the home. What we're seeing in the right-hand picture is embers igniting debris in gutters and embers igniting mulch on the ground, resulting in flames touching the home. I'll show you a video of that right-hand picture study in a minute. So I think we've come to learn over the years that homes and buildings survive wildfire most successfully if a coupled approach is taken. And the coupled approach means that you take care of things on the property and you take care of things on the home itself. So we can use this picture as an example. So you can imagine that should this vegetation ignite, that the fire could burn directly to the home in this case, and then that home would have to resist the flames touching it and the radiant heat as the flames from that spot fire or the ignited vegetation near the home burns to the home. But you can imagine that if all of that greenery were not there at all, sort of perfect in a matter of speaking, from a lack of combustible things, that embers can fly over. Embers can fly upwards half a mile, reported much more than a mile. But I think to have enough embers and enough embers of a given size and energy, you're talking half a mile or a quarter of a mile, anyway, bigger than the property of most people that I know anyway. So embers can land on or near the home, and that home still has to resist the embers. So there's a lot of ember things for the home, and then the purpose of what you do on the property, it's called creating your defensible space. It's also called the home ignition zone. There's a lot of things it's called, but really it's how you select, locate, and maintain vegetation and other combustibles that are on the property. So other combustibles would be a tool shed, would be your wood pile, would be your RV, anything that can burn. You want to make sure that should those ignite, they're not going to have a negative impact on your home. So this coupled approach, I think, is pretty important. So I'm going to show you a quick video and to make sure that take the sound down. So this was a 2011 demonstration. These were our first generation Ember generators. So it was rather a batch process. We now have more continuous feed generators, so they can run for much longer. And in this particular test, we are using common construction materials and common things that might be located near the home. Here's the generators working. You can see embers accumulating on the screen on this window. You're going to start seeing ignition of bark mulch on the ground, pine needle debris in gutter. There will be ignition of debris in the valley. You can see the vinyl gutter detaching and falling to the ground, sort of because it becomes a what's on the ground problem. The metal gutter that was on the right-hand side stays put, and it is and remains an edge of roof vulnerability or threat. And you can see there the debris in the valley burning. Again, another shot of the detached vinyl gutter. The re-entrant corner, which got a pretty big fire going there. That's what made us extinguish this particular fire. We wanted to maintain and save the house. But in any event, you see what embers do, and you saw a lot of examples of indirect ember ignition. You can see this is a plastic-clad fiberglass screen in the window. It really did a good job of keeping embers out of the interior of the building. We left the window open on purpose but once flames touched this screen, window screen, the screen failed and flames and embers could then enter. So you saw some examples there of what embers can do. So I'm not going to really spend a lot of time at all on this defensible space component, except to talk a lot about this ember resistant zone, this near home zone. You've maybe heard it called the non-combustible zone, the low combustible zone, the ember resistant zone, zone 0. Firewise calls it the immediate zone. It's the zone that's right next to the house. It's nominally a 5-foot zone, and it includes under the footprint of any attached deck. And the idea here is that because of the importance of the ember and the ability of windblown embers to fly over any defensible space or any property that most people have control over, you minimize the opportunity for embers to ignite the home if you have non-combustible areas right next to the home. You really can't expect, as we see in this lower right-hand picture, you really can't expect your deck to survive a fire of your own personal lumberyard that you might have stored there. Before embers enter into the crevices between these boards, debris has already gone there. So there's a lot of fine fuels in there already. The embers can easily ignite that fine fuels, which will then ignite the larger wood members. Flame impingement on the underside of the deck is really a hard thing for a deck to resist. And then that burning deck will ultimately lead to the ignition of the home itself, either by breaking glass in the sliding glass door or access door or siding, any number of ways that a deck can threaten the home should the deck ignite. So we want to really focus on this as part of this coupled approach. And sort of in part and parcel with this horizontal zone right next to the house, we need to make sure that we have this vertical zone between the ground and the start of the siding. So you want to have an area so that embers that land and stay put in this ground to exterior wall intersection don't have anything to ignite there. The right-hand picture shows a test I did when I was with IBHS, where we had 3 different wall sections with different non-combustible clearances, 6-inch, 0-inch in the middle, and then 2 inches on the left-hand wall section. The only one that ignited was this 0-inch, but you clearly did ignite, and you had this concrete floor to vertical wall section. So embers do land and stay put there, and they can ignite should this siding go all the way to the ground, because embers will accumulate against it. We recommend 6 inches just because it's more conservative number, and it does allow for a certain amount of combustibles to sort of accumulate there, or to have some sort of ground cover in proximity. So anyway, the 6 inches is the guidance, but if it's only worrying about embers, less than that works. But if we realize that there are sometimes other things to worry about that can accumulate there over time. And even if you have a combustible siding material, often, as we see in this picture, you have combustible components in the wall assembly that overhang the perimeter stem wall, whether it be a stem wall or a slab on grade kind of construction. You do have combustible things that hang over the edge. And so even with non-combustible cladding, you still need to worry about this zone, because in this case, you can see that flames would impinge on the bottom of this wall section, potentially igniting the sheathing that we see here and moving into the house in that way. So regardless of the cladding type, this is still a good guidance. There are times when, so we've talked a lot about embers, there are times when radiant heat or flame contact is definitely more important, and these are in neighborhoods where you have close home-to-home spacing. We see this, not most recently, but a good example of this was the Tubbs Fire, Coffee Park, Santa Rosa, 2017, I think. And the amount of loss from this, and this is a large part of home to home from radiant heat or flame contact. Because of the high winds, you can anticipate some flame contact exposure because the wind's pushing burning buildings into the adjacent building. So these are examples where materials are much more important. Often lost my train of thought there. We'll just move on. So this is an Eastern Tennessee picture, fire in Eastern. It wasn't the Chimney Tops 2 fire, for those of you that follow this. It was a fire that occurred the year before. And it really demonstrated the importance of radiant heat and how that can be used, how that can ignite neighboring homes. So in the left-hand picture, we have a burning home. This is a large home, and it is threatening and breaking glass in the window in this under eave area on the home on the left. And in the right-hand picture, this sort of fully engaged home is the same home that was just starting in the left-hand picture. So this is a good example of radiant heat and the importance of radiant heat and the importance of being ready for radiant heat. And this is often when neighboring homes are nearby. We'll talk about some of the things that we can do for this during the course of this presentation. So I think when you think about homes you might be designing or building, and what might be important, it's useful, I think, to think about where the home is on the parcel and what's near it. So if you are building a home on a large lot, it is all about the Ember, as long as you have really good defensible space and can take steps such that fire can't burn to the building, or that the burning thing isn't close enough that the radiant heat from it it's sufficient to break glass in the window, for example. If you're on a steep slope, then vegetation management becomes a pretty important thing. Downslope, and you might want to do things to harden your deck or make your deck more resistant. We could talk about some of those things along the way. So, and then if you're in a neighborhood where the neighboring home is pretty close, let's say within 30 or so feet, then non-combustible cladding is important. The dual pane tempered glass becomes much more important. You can consider other kind of things too, such as maybe a deployable shutter for the window, maybe a fancier flame and ember resistant vent. So depending on your situation, you can sort of think about how you might want to use different strategies to provide additional protection for the home that you're working on. So I think we're going to take just a few minutes now to just review some of the terms that are used to describe the fire performance of a material or a wall. So we have non-combustible, those are there's a standard test for that, but those are the things that don't readily ignite. And then we have a lot of combustible things. When we're talking about combustible things, there's different terms or different tests that are used to describe their performance. There's the flame spread index, a class A, B, or C. There's an ignition resistant material, and it's the material versus the construction, which is more of a generic term. I'll show you some pictures of some of these tests in a minute. There are some standard test methods that California has adopted through the State Fire Marshal's Office. Most of these are now, or actually all of these are now, I'll back it up. Most of these are now State Fire Marshal standards. They are State Fire Marshal standards, and many of them are ASTM standards also. But these are ways that combustible materials can comply in the state. And then there's fire resistant ratings for walls. This is like the 60-minute wall, the 20-minute window. These are a particular test for that. And then of course there's the roof fire rating for roof coverings, class A, B, or C again. So there's, you know, class A or B or C for roofs, and there's class A, B, or C for flame spread. And these are two different kinds of class A, B, and C. So you just have to know which one you're talking about. So this is the Steiner tunnel. It's used in two ASTM tests. The ASTM E84 is a test used to get the flame spread index. In this case, the material, in both cases, the material is located on top of the tunnel, and then you monitor flame spread down the tunnel on the material. And depending on how far it goes down the tunnel, you're going to have this flame spread index of A, B, or C, with A being the best. This test is 10 minutes long. A 30-minute long test is used in ASTM E2760, and this is the test that is used to have the designation of an ignition-resistant material. And it has also a prescribed distance down the tunnel from which it cannot exceed and still have that class A or ignition-resistant material designation. Anyway, so Steiner tunnel for those two things: flame spread index and ignition-resistant material. If you want to know materials that comply with the state, you can go to the State Fire Marshal's Building Materials Listing Program. You're going to come to a page that looks like this, and you're going to fill in the thing you're interested in this category. So I've picked, in the right-hand part, I picked decking for wildland urban interface. This would be decking products that comply with the state's test. And you hit search and you can find products that comply. You can do this for decking, for siding, for things that comply with ignition resistant material designation. That same test we saw on the slide before in the state of California, Chapter 7A allows those materials to be used, so you can find out what works there. And then also they have a listing for vents that comply with their flame and ember resistant criteria. The best way to get here is to do a web search, California Office of the State Fire Marshal Building Materials Listing Program, and it'll be the first or second thing on your search engine result. And it's a really convoluted URL, but that'll get you there. This is the vertical tunnel, the vertical furnace that is used to get the 60-minute wall rating, the 120-minute wall rating, the 90-minute wall, whatever rating it is. This tunnel is used, you ignite these little dark spots here are burner nozzles. You ignite them all, you put the wall in place, and you run the time temperature curve that you see on the right-hand side. If after the designated time, the fire doesn't burn through the wall, and there's a couple of other things that have to happen for it to have this designation of a 60-minute or 90-minute or just whatever the minute rating is, but it's tied to this time temperature curve. So this is that apparatus. And you'll note, if you've read the building codes at all, that 1 hour, that one half of the exterior part of a 1 hour wall is one way that siding components can comply. This can be a horizontal furnace for floors, for WUI kind of, or wildfire kind of things. We are mostly interested in the wall part, this particular vertical furnace part. And then there is the standard test method for roof coverings. So this is the brand part of the test. This is the ASTM E108 test. And there are 4 components to it. This is one of the components that the roof has to comply with all 4. This is the part though that gives it its name, the Class A. This is a Class A brand, burning brand on top of this roof covering. The right-hand picture shows flames coming through the roof covering into what would be the attic space. So as constructed, this roof is not does not have a Class A fire rating. they have to do something else to it in terms of assembly, or change the roof covering material to make it comply. But so with this test, you don't want the right-hand picture to happen. If you don't have flames coming through, then you do have that designation, and you can say so. The code is changing in California, so that everything will have to be a Class A in the next go round. So let's talk about the building component by component. So on the right-hand side, right-hand picture, you have a red circle and a number of yellow squares. So the red circle is what the fire rating of the roof covering tells you about. It tells you about the field of the roof and how it performs in the field of the roof. You can be a Class A fire rating, for example, by the covering alone, or by an assembly rating where you have additional materials in the assembly that helps with the fire resistance of the covering assembly, of the roofing assembly. So on the left-hand picture, we see that we have added a fire-resistant material above the sheathing, below the roof covering, and there are some materials that need this kind of additional fire-resistant material to get the Class A rating. That's all that the covering, the fire rating can tell you. The roof can be vulnerable at these roof to other component edges. So at a dormer, at a split level, at a skylight, at a vent, at a gutter, the fire rating of the roof doesn't tell you about these things, about how that roof might perform. And so we're going to talk a little bit about that in the next minute or two. So here we have, again, from that demonstration in 2011 at the IBHS Research Center, we have embers igniting debris on this Class A fire rated roof. The right-hand picture shows damage from that material. So the fire rating doesn't mean that the covering won't be damaged. It means that the fire won't burn through the roof covering into what would be the attic space, or in this case, into the attic space. So here we have a debris on the roof that burns, there's damage, but there's no failure. And so this is, the roof covering did its job in this case. Where we have to worry about debris on the roof is where it meets other things. Here we have a roof covering adjacent to a split level house, and on the left-hand picture, and then another picture from IBHS where debris ignited that accumulated in this roof to wall intersection at a dormer. So in these kind of situations, the siding, I would argue, would be the vulnerable component of the roof when you have a Class A roof cover. So you want to make sure that the adjacent thing provides protection that is comparable to the Class A fire rating of the roof. And in this situation, you have the siding that could be more vulnerable and this under-eave area that could be more vulnerable. So you want to make sure that both provide similar protection so that the siding doesn't become the more vulnerable component. You probably know that at a roof to wall, you can have siding come pretty close to the roofing material. It's because of what embers can do directly. It's a good idea to have a bigger separation between the roof and the start of the siding. You can do that by taking the siding off and or using this, what we show here, more of a flashing, metal flashing. I think when you have this metal flashing detail, in order to avoid moisture-related degradation, you need to make sure that flashing tucks in behind the siding so that water cascading down the wall will go over top of the flashing and then off the roof. You don't want the water to get in between the flashing and the siding. That would result in some moisture degradation problems that you don't want. Another vulnerability is at the roof edge. And as we see in the lower left-hand picture, that roof edge can be at a ridge. In this case, it's on a hip roof. But these areas are where debris can enter and accumulate over time, and embers will also enter there during when a home is threatened by wildland fire. So you want to make sure that you plug these areas with something that that minimizes the accumulation of debris and also the entry of embers during a wildland fire scenario. So you can do that on the right. Oh, sorry about that. On the right-hand picture, we have a homeowner do-it-yourself job where he's using a mortar mix to plug the end of a barrel tile roof. I caught him sort of mid-job, and so I'm sure these are done by now, but this is just to show you how it was and then what his repair was or fix was. I think this was a good idea. You can use any number of products, and non-combustible is probably better. So you can use something like a mineral wool bat insulation product and sort of stuff it in here. The idea is to plug these openings at the edge of the roof. So here's a gutter issue. I think we often, guidance right now and code in California is to have a gutter cover. It's always better to have a non-combustible gutter cover. And that gutter cover should be linked to a drip edge, a metal drip edge. This does a really good job of protecting the combustible components at the edge of the roof, at the drip edge. And then the gutter cover should do a good job of keeping debris out of the gutter. You'll note, if you walk around and look around, you'll note that some gutter covers just force the debris to accumulate on top of the roof and back of the gutter cover. So from a homeowner perspective, at least, it's not a maintenance-free kind of scenario, but it should be a reduced maintenance chore or job. And I would argue that a Class A fire-rated roof covering is in a much better position to resist debris that might ignite from embers that's on the roof itself as opposed to in the gutter where the flames impinge on the edge of the roof. This is the left-hand picture, lower left-hand picture is from one of the research projects at IBHS. This area did not have this drip edge installed, and you can see the burned out embers that entered at this top of fascia edge of roof sheathing gap. And there's another picture to the right. You can't really see it so well, but this building had sort of a split part. So part of the edge of the roof had a drip edge and part did not. And this is the part that did not. The part that did, there was really very clean soffit, so no ember entry there. And then the reason for having a non-combustible gutter cover is, as we see in this right-hand picture, debris can accumulate on top of the gutter cover. You don't want that to be a combustible material, so you want that gutter cover to be non-combustible. And there are a number of options on the market these days. So here's a picture from my colleague Jack Cohen from one of the post-fire situations he was visiting and studying. And this shows again so here we have debris in the valley, but also debris in the gutter. So we saw a couple of slides back of how a Class A roof can sort of handle burning debris in the valley. And this shows you, this left-hand picture, right-hand picture shows you how this is a same home, just different sides, how ignition of debris in the gutter can burn through this fascia sheathing intersection at the roof edge and get into the attic space. So reasons for gutter cover and a drip edge. Skylights are two basic kinds, you know. There's a dome type and there's a flat type or glass, dome type or plastic. All the guidance says go to glass. It's just sort of a gotcha that on a flat roof, flat skylights are much more likely to accumulate debris, as we see in this middle picture. Dome skylights are less likely. But should the debris ignite, the flames could impinge, I think, on the plastic. So, you know, I think in general, the glass is a much better option. If you have an operable or open skylight that opens, you'll have some screening in there. You know, guidance to the homeowner is to close windows when they evacuate, and the same would apply to an operable skylight. Make sure it's closed when evacuation occurs. So I think we've come to the first section or stop point, and we're going to take time to have a few questions. So if there are any.
All righty, can you guys hear me now?
Can, yes.
Great, okay, so we do have some questions coming in here. So the first one we have here is it ever a good idea to treat shake roofs, or do you always recommend a Class A roof?
So by shake roof, I think you're going to be saying, talking about a wood shake roof. So just in general, topically applied coatings in general, we'll talk about this in a minute in more detail, but coatings have not been shown to weather well. And so coatings should not be relied on to provide protection at this point. There's a lot of interest in making coatings work better because arguably they would be an inexpensive way to provide protection to a vulnerable part of your home, whether it be siding or roofing. If you have an untreated wood shake, your first priority would be to change that out to go to a Class A. There are Class A pressure impregnated, exterior rated, fire retardant treated shakes that are available. They're pretty expensive. In California, they've gone through the natural weathering cycle that is needed to be approved for use in the state, but most jurisdictions, in California at least, do not allow shakes, whether they're fire retardant treated or not, because of the uncertainty of the longevity of the chemical. So I'll leave it at that. We can talk about that a little bit more when we talk about coatings, if there's still some questions about it. But the bottom line is a coating that you apply with a brush or whatever is not recommended.
Great, thanks, Steve. Next question here. Do you recommend filling the space between the roofing materials and the roof deck with, specifically the slots on a metal roof?
So I think you could use, as I think we addressed that earlier, but you know, I think a good option, if you're doing this on a roof that's already installed, I think stuffing it with a mineral wool is a good option. It can conform to that little opening. I can agree that it might be a little bit of a labor intensive. If you are installing a brand new roof, you know, there are wood items that would, you know, I forget the term, but a contoured wood shape that is pre-made that could be installed. It is combustible, so if you have a lot of debris in the gutter, that would not bode well for this particular situation. But if all you're trying to do is keep debris out and embers out, then that could be another option. But if the roof is already in place, you know, I would say a mineral wool batt material would be a good option.
Great. And what about flat roofs, such as over a garage? They tend to be covered with tar for waterproofing. Is it enough to then add a thick layer of gravel over it and make sure it's not covered with pine needles or leaves?
Yes.
A quick one. We already answered that one. Are there loans, grants, tax deductions for homeowners who want to upgrade their older home to a Class A product?
So that is a very good question. There is a lot of talk about that. I would say where you are, you should check with your local authority. Check with your building department or your fire department. Some communities are receiving FEMA grants that subsidize, let's say, so the homeowner has to provide some amount of funding. Is typically 30%, let's say, of the thing, so 30% of the total. And there has to be some defensible space upgrade component to it, but these things are possible. I know in the state of California, there's a lot of discussion about that within the legislature. I think there are issues with funding these days because of COVID issues that made money that may have been available sort of less than available right now. So I would just check locally, because there is money available or becoming available in some communities, and you can just check to see whether that applies to your community or whether it's likely to apply to your community.
Great. Regarding your mention of the code changing in California, will it go to Class A assembly or just Class A covering? Curious, as we are just going through a code change in Boise, Idaho. Thank you, Steve.
It'll be a Class A assembly. I think that's what the wording is. If you, Amanda, maybe if you could just give well, my email address will be at the end of this thing, but if there's a general email that you want to provide, Amanda, that they could ask, I could check to be sure. But right now, assembly is allowed. An assembly rating is allowed, and I don't think that changed, but it will require Class A in every fire hazard zone. So.
Perfect. And yeah, we will be sending out a follow-up email with a form for folks whose questions didn't get answered, so they could submit them there. All right, we probably have time for one or two more for this section. So for wall-to-roof interface, rather than try to add that tricky flashing, wouldn't it be better to just replace the siding in that one area with fiber cement?
Thank you so much for that. You know, I meant to say that. So whoever you are, I really appreciate this question, because it allows me to backtrack and say what I had intended to say during that slide. This is one area where I think if you tell someone to replace every bit of siding on their home, it can be daunting. But if you have an area like at a roof to wall or split level home or on a dormer, sort of a more limited area where you can replace siding, what I say locally, you know, not everywhere, but just in these certain places, and improve or reduce the vulnerability of your home, you know, that can make an unaffordable thing very affordable, or more affordable, let's say. And so yes, that is definitely something you can do. And I think the other nice thing is that we're talking about fiber cement generally, that they have patterns that look a lot like wood patterns. So you know, you can match, you are pretty closely match, and so you can have a similar look even though it's a different material. So yes, definitely you can do that, and I really appreciate your question. Thank you.
Great, and let's do one more here. Is it better to have vinyl gutters which melt and fall away, or metal gutters?
So I think it's best not to have debris in the gutter. If there isn't debris in the gutter, then the metal gutter and the vinyl gutter are pretty resistant to ignition to this direct ember ignition. Both of them resist that pretty well. It is the debris that makes both of them vulnerable. And whether, if you're gonna assume you're gonna have a lot of debris and you wanna know, what's the better one to ignite, then I think you need to look at your home, because in the edge of the roof has a vulnerable part. If you don't address that, it will be a problem. And with a vinyl gutter, it will be an edge of the roof problem for a little while, and then it'll become a what's on the ground problem for the rest of it. And it's a question of what happens there. If you have this, if you have combustible siding, I would say metal is the better way to go, just because of the implications of things falling into the ground. But I would not ask the question in that way. I would say, what can I do to keep debris out of my gutter? Because that's the problem. And that problem is addressed with gutter covers that minimize the accumulation of debris and make this ember at the edge of the roof not an issue.
Great, thanks, Steve. Those are super helpful. And thank you, everyone, for being patient with our technical difficulties. I think we're smooth sailing now. But all right, so that's all the time that we have for that section. Steve, you're probably good to move on.
Okay, I really appreciate the question, so thank you so much. We're going to spend a little bit of time talking about vents and the exterior wall. So I'm talking to, I think, largely to people that know some of these things already, but the roof and the home can have a lot of ventilation. All of these attic and crawl space areas are ventilated typically. We'll talk about the unvented part in a minute. And you know that the under eave area is where the air comes into the attic space, for example, and then there's a number of places where the air can exit the attic space. And these are through roof vents or gable end vents. The through roof vents can be through the roof or at the ridge. So you can have some combination of these things. And then for the crawl space, you're going to have cross ventilation. You're going to have ventilation on all sides, let's say, in order to help with moisture management in these areas. The attic, there's a temperature thing going on also. Unfortunately, these vents are places that embers can also enter during wildfire. And so you can have ignition of things in the attic. I think many of us that have attics, we actually don't happen to have an attic in our house, but many of us that have attics store stuff in them. And it's this stuff that can be pretty combustible and result in ignitions occurring in the attic space. So we want to talk about vents in terms of their vulnerability to ember entry. This is from an experiment that we conducted at IBHS a few years ago, and we were evaluating the potential for ember entry through all kinds of vents that would be in the attic. The left-hand picture is a gable end vent. The right-hand picture is vents in open eave and the blocking of open eave. And you'll notice that they come in these areas pretty readily, but you also notice that they go here and there. They go hither and yon. And we did a lot of experiments. This attic space was not insulated. It had a lot of wood in it, though. We did not ignite anything but a piece of paper that happened to be on a little desk that was in there. So, I mean, the thing is that it's these finer fuels that are more readily ignited. So it could be sawdust, it could be bird's nests. I've seen bird's nests in attic. It can be cardboard boxes of things. So that we need to worry about these items, and we're going to talk about what vents are more or less vulnerable. The thing that was very clear is that the gable end vent and the venting in open eave construction, these vents that that present a face that's perpendicular to the flow of air are very vulnerable to the entry of embers into the crawl space. So I'm going to show a quick video here. I'm going to sort of set it up a little bit. This is a camera that is inside the attic space looking across, it's looking across at the entry of embers entry into a gable end vent. And so you can see everything coming in. And this is I'm using this just to show you how mesh size can influence the number and the size of the embers that can enter. So let's just play this thing. So 1/4 inch mesh, you can see them coming in, passing from left to right. The number is large. The ember size has to be smaller than 1/4 inch because it'll just burn on the outside of the screen until it burns down to that size and then enter. So we're going to watch 1/4 inch for a little bit, and we're going to watch 1/8 inch. Here's 1/8 inch. You'll notice that the number is reduced, and importantly, the size is reduced. But still, you have a chunk of them coming, and but you would need more of them maybe, or in order to ignite something in there. Attics are usually hot and dry places, and so things that are in the attic become dry. And here we have 1/16 inch, so even smaller, arguably even fewer. And you can see the embers accumulating on the outside mesh, and they're going to burn down and then come in once they reach that size that allows them to enter. This is just a demonstration to showing what vents do. They moderate the number of embers and have a definite influence on size. For a gable end vent, all of the 1/16 inch entering embers, they self-extinguish before they hit the ground. It was a gable end vent, so it was a couple of 3 feet from the attic floor. I don't want to show that again. So you know this, but open eave design, the left-hand picture, vents in blocking, between joist blocking, soffitted eave design. Typically there's a strip vent for a ventilated attic design. And we see that in the far right-hand picture. As I said, the vents in open eave are far more vulnerable to ember entry, and vents in soffitted eave are not. That parallel orientation, embers enter, but just not nearly as many. So if you're looking at minimizing ember entry, soffitted eave is the way to go. Finer mesh screening, also from strictly an ember perspective, the way to go. But finer mesh screening from a homeowner perspective or resident perspective, more of a maintenance issue because of the ability for dust and other debris to gunk up that screen, making it harder for it to do its moisture management function. The upper left-hand picture, it's a 1/16 inch mesh screen, easy to paint over, and not really thinking about that when you're painting. So, you have to be careful about this. The right-hand picture is an 1/8 inch mesh screen. Over time, easy to gunk over. So this is just an awareness that the homeowner needs to have in terms of this. From a wildfire perspective, you really want to go with finer mesh screen. The homeowner just needs to be ready to do a little bit more maintenance. You can also notice that this screen in upper left it needs repair because it's really detached. So it's not really doing a job at all from keeping embers out or even small rodents out. We found that if you have a ridge vent, that this exterior baffle does a really good job of minimizing the entry of embers. It's plastic, so it's not really a good thing to have on the roof. And we see the example of why not in this lower right-hand picture. Debris will accumulate at the entrance, and so embers will ignite. Then you have flaming exposure to this plastic vent. There are metal ridge vents that have this exterior baffle, external baffle. You know, this was a good performer from an ember exclusion perspective, but because of this debris accumulation potential, if you want to go the route of a ridge vent, you should go the route of a metal one, a non-combustible one. There are a number of flame and ember resistant vents that are approved by the state of California. There are there's an ASTM standard test method that these vents must comply with, and you can go to that building materials listing page on the State Fire Marshal's website and see which vents comply currently. There are these 4 vents that are currently commercially available in the state. Upper left is Vulcan. It uses a honeycomb mesh that has an intumescent coating on it. That's the flame part. And then there's a screen in back of it. That's the ember part. Lower right is O'Hagan. It's strictly a through roof vent. The Vulcan and the Brandguard in particular, they have made components for different vents. So you can have a gable end vent, a crawl space vent, an open eave, a vent and an open eave option, and even a through roof vent. And Embers Out does the same thing. Anyway, O'Hagan is strictly a through roof vent. It has this steel wool mesh that are steel wool fabric in the inlet area that you use that for the ember and the flame part of its design. You'll notice that they use, they can use different features for flame compared to ember resistance. Brandguard uses a baffle design, so things need to turn corners to get from the outside to the inside. Some Brandguard vents also have an intumescent tape that is used for enhancing flame resistance. Embers Out uses a steel wool mesh, and this one, it has a wind-driven rain rating also. It has a little drip, an exit place for water at the bottom. These are the options that are there. These are far more expensive than 1/8 inch mesh screening. So this is something that you'll need to sort of evaluate. But there are certain situations where flame and ember resistant is really useful. And this is sort of the unspoken yet, but there are unvented designs out there, and you get around the need for a vent altogether. You can do this for a crawl space, you can do this for an attic space. So I think, I mean, you need to check with the local jurisdiction to make sure that they're copacetic with an unvented design, but this is definitely an option. It's easier, I think, to do with new construction. If you're retrofitting existing, there's a lot of penetrations that might be hard to get to between the living space and the attic space, for example. That might allow moisture to get into the attic space and no way to get out of it. So, you know, if you're doing a retrofit, you need to be pretty careful. And there are, because of ice damming issues, sometimes you have a harder time getting approval or using this kind of design in colder climates. But it is an option. You want to make sure that the roof covering you have isn't going to be negatively influenced by having the foam so close to the roof covering. I think you sort of understand that when you go to this unvented design, you're moving the thermal barrier from the ceiling to the roof, or in this case, to the under roof area. And so that foam insulation that is good for air barrier kind of things, you don't really want it to have a negative impact on the fire performance of the roof. So exterior walls are vulnerable, combustible walls are vulnerable from a couple of perspectives. One, as we see on the left, is that it ignites and you have a lot of flame spread all over the wall, impinging on everything in its way. And then there's flames entering into the stud cavity and then into the built environment, to the occupied space itself by penetrating at a lap joint or through the field of the cladding, whatever. The California way to comply that state fire marshal standard and the ASTM accompanying standard, it's strictly a fire penetration standard or compliance pathway. You can have a lot of flame spread on the wall as long as fire doesn't penetrate through a lap joint. You can be good to go. So this is something to be aware of. If you are using a combustible cladding product from a fire penetration perspective, a more complicated lap joint like the shiplap on the right is far better, far more resistant to flame penetration than the plain bevel that we see on the left. So shiplap, tongue and groove, these are good options for improving the fire resistance of a lap joint. The plain bevel, not so good. This applies only to combustible cladding. I think that fiber cement often uses a plain bevel lap joint design. And this vulnerability of the lap joint doesn't really apply to a fiber cement product. It resists the penetration at the lap joint pretty well. A lot of us, I think people tend to think that good siding is the only thing you really need to have. And whereas there are definitely situations where non-combustible siding is really beneficial. We talked about some of those situations earlier. But as you can see here, it isn't everything. The upper left picture is from the 2003 Cedar Fire in San Diego County. The right-hand picture is that big box store in Santa Rosa during Tubbs Fire. So if you look on the inside of this wall here, it's a completely destroyed inside of that big box store. The Dollar Tree store is pretty happy, I'm supposing, because this was a really good radiant barrier to the tree and to the other part of the mall here. But Ember's got in, a big box store, it had to have been Ember's because big blacktop all around it, parking lot. So sidings can be important, but if you don't have the other things in line that impart Ember resistance, the siding will not protect the building. So this is an example. The right-hand picture is an example of that. This is another test at IDHS and really showing this challenge, let's say, when you have siding where vertical and lateral flame spread can happen. Here in this particular situation, we had embers igniting mulch next to the building. That mulch, flames from that mulch igniting the siding, flame spread laterally and vertically to the window, to the gable end vent, and to that under eave area on the rake end of the building. Fire entered the attic space through the vent and through that under eave area long before. And in fact, fire penetration through the siding never happened before this whole thing was extinguished. So sometimes the glass broke. They did this test a few times, and sometimes the glass broke, sometimes not. But in each case, it was a single pane, non-tempered window. So the left-hand picture is this part of a 1 hour design, a wall that is used in California and in other building codes that allows a cladding material to be used as long as it can pass this 60-minute or be 1/2 of the 60 minutes, so the part that you can see. And this, means that flame spread can happen. And so you really want to make sure that when you have these kind of things, this kind of design in your wall, that the window, the vent, and the undereave area are helping you. I think the thing is that when siding ignites, this is another reason for this non-combustible zone or near non-combustible zone near the home, because when siding ignites, it just becomes a problem for the home, and it's really difficult to have that home survive just because there are so many potential weak links that you need to address. Whether or not fire penetrates at the siding itself, you have these other things that can be weak links. This is just a study that I did with some colleagues back when I was with, several years ago when I was with the University of California. And it just shows that in addition to the open eave construction being more vulnerable to Ember entry, it, because of this boxed in feature that you have with this blocking and blocking joist roof sheathing cavities that are built, you have much faster ignition and much quicker lateral flame spread when you have this open eave design compared to a softened eave design. So there's a couple of reasons to opt for softened eave, but really you need to be doing what you can do to stop that wall from igniting at all, because as what we've just been talking about. So we did talk a little bit about this with the question earlier in terms of coating. This was a spray-on coating for a roof, a wood-shake roof. But I think it applies to other kinds of paint coatings also, the question. And often these are intumescent coatings. These are coatings that when they get hot, either from radiant heat or flame contact, they swell up and become an insulating layer. This is used in the Vulcan vent and in some of the brand guard vents. And there's a lot of interest, I think, in using these kind of coatings on combustible siding. And arguably, it would be a cheap strategy, an inexpensive strategy, if it worked. So at IBHS, when I was there, we did a study in collaboration with the University of North Carolina at Charlotte, and we found that they don't work. We picked only coating products that marketed themselves as being good for 5 years, and within a year they were performing no better than uncoated wood. And NIST, and the National Institute of Standards and Technology, they did a study also recently and basically confirmed what we found. So that's one reason. Another reason, if you're in California, the California Building Code states flatly that you cannot use a coating as a means to comply with the provisions of the code. So you cannot use a coating, to meet any part of the standard, excuse me, of the building code. The lower picture is just the test wall where we naturally weathered these coatings before sending them to UNC Charlotte, where they did some fire testing on the material. So hopefully that takes care of that. I know that there are coating manufacturers out there that really want to have a viable product. So if you are approached by them, your question should be, show me the data, show me the fire test after weathering. And doing an outdoor natural weathering takes time. And so there are artificial weathering procedures. You want to know how they're judging the duration, their expected service life. And so they have to have done some weathering and testing fire testing after weathering in order to come up with some idea of how long they're going to last. These coatings are several times, like 3 to 4 times thicker than a normal paint film. And so you're adding a lot of thickness to the wall, let's say over time, if you're reapplying these things over time. Okay. So spend a couple of minutes on windows. There's a couple of ways windows can be vulnerable. One is that glass breaks and flames enter. The other is that, or embers enter. The other is that the frame ignites and then the fire enters that way. A lot of tests have been done on windows, and it's pretty clear that the most vulnerable part of the window is the glass. And that's why the Chapter 7A, at least, and other codes really focus on the glass itself. California requires tempered glass in a multi-pane IGU unit. The window, you can see in this sort of figure here that the glass becomes vulnerable because of the temperature differences between the protected glass, the glass protected by the frame, and the glass not protected by the frame. You have these temperature differences, and you have these cracks that propagate inward from the edge. Enough of these cracks propagating inward, it falls out. So you have the outer layer protecting the inner layer first, and then so that the exposure has to be long enough to get both panes of glass in this dual pane system. And having tempered glass really just increases that time. So there's one sort of gotcha about being indifferent to frame, and that is with vinyl windows, particularly the hung windows. And as we see in this picture here, you really want to have the frame in this horizontal meeting rail and this hung window to have, as we see on the right, this metal reinforcement in this meeting rail area. If not, as we see in this left-hand picture again, at radiant heats far less than that required to break the glass. You have deformation of this rail and the IGU unit just falling out at far less exposures required to break glass. You have they just falling out and landing on the ground and breaking. So you want to make sure that it has this reinforcement area. If it does, then you can be indifferent to frame type. And if you have an AMA rated window, it will have this reinforcement in the meeting rail area. Others may also. I happen to know that AMA rated windows do have that. And there are situations where a shutter would be beneficial to help protect a window, a deployable shutter or other kind of thing you put on the window when wildfire is threatening. But again, coming back to the Ember, there are other ways that a home can be vulnerable. This is the Southern California fire again, and it had a shutter that was deployed, but the home was destroyed because of other vulnerabilities in the home. Okay, another stop point for questions.
All right, we're definitely getting a lot of questions here. So a question for this section. Can you discuss the differences between screen sizes, 1/8 inch or 1/16 inch, versus the various special vent covers like Vulcan brands? And how can one find the WUI certifying of these vent covers? I have heard of these certifications, but don't know how to find them.
So we talked about each of those, and so remember that video we showed how the various the mesh sizes affect the entry of embers. Mesh doesn't really do much to stop all flame. So we're really talking about mesh for ember entry reductions. And we showed those vents that you asked about, the special vents, and just remember to do a web search on California Office of the State Fire Marshal Building Materials Listing Program, and then go to the site that is the CAL FIRE site. Sometimes when I do this, there's a different county site is the first one. You want to go to the state site, and that'll take you right to that page where you can just you can scroll down in that categories area to vents, and then click search, and it'll give you all of the vents that are currently accepted by the State Fire Marshal's office. If this isn't clear, just send an email to us, and I'll try to answer it more clearly.
All right. And in the interest of time, we'll probably just do one more for this section. Can you recommend a soffit eave assembly or fire hardened homes for fire hardened homes, and what kind of venting is recommended in a soffitted eave?
So the number of options are sort of out there. There's fiber cement has a soffitted eave, have soffit material. You can use wood options as long as you have good near home zones to minimize the chance of flames burning up the wall and impinging on that soffit area. You can be more flexible in the materials that you use, but a non-combustible option is never a bad idea. But there are just situations where you don't need to worry so much about that, and you can do it as an aesthetic thing. And then the vent option, for fiber cement, they do have perforated soffit options. So you have the holes already there. They're 1/8 of an inch holes, so pretty small. You want to make sure that otherwise you can use a strip vent. These are metal strip vents that you can position somewhere in the soffit. I would suggest or recommend that you put the strip vent as close to the roof edge as possible. So as close as you can get it to the gutter is a better, even less vulnerable part than closer to your exterior wall.
Great, thanks, Steve. And like Steve mentioned, we will be sending a follow-up email probably sometime early next week where we can try to answer as many of these questions as possible. And we will have a general Q&A session at the end of this. So if your question didn't get answered, don't worry, we'll do our best to make sure that it does.
Okay. So I'm going to keep on going. We're almost done, and I see that we are, I am more long-winded than I anticipated. So we'll talk about decks and then fences, and then we'll be done. So decks, they can be vulnerable from flames from below or embers from above. The non-combustible area under the deck is supposed to address flames from below. We're going to talk about embers from above. This is a pretty cool picture I like. The left-hand picture, this shows where embers accumulate when you have a pretty smooth surface emanating out from the building or your home, a home. They accumulate at the wall to ground or wall to deck, and then there's a stagnation point a few feet beyond that. If you have something in the way, they'll stop there, no doubt about it. But a deck is smooth enough that if there's not a piece of furniture or whatever, it'll come out and stagnate a few feet from the building. It's a function of the height of the building, so 4, 5, 6 feet, depending on the height of the building. The right-hand picture, embers will get at this wall to deck interface. So you want to make sure that you do things that make this less vulnerable. You can have, if you have combustible cladding, you can have a metal flashing that comes around. You can, if you have a wooden deck board deck, you can use a metal deck board option, next to the home. We'll talk a little bit more about that in a second. And then the other place where embers accumulate is in the deck board gaps, and they'll stay put if they happen to land where a joist is. If they land where a joist isn't, it'll fall through the deck board gap onto the ground below. Another reason to have a non-combustible zone under the deck, because embers will land there even if you completely block off the front of the deck. Embers will get there by going through the deck board gaps to the ground below. This is one of the cooler experiments I did at IBHS, and it really showed that flames can burn to the building as a really tiny flame. And then it's really what's happened when you get to the home in this case. But embers will ignite the deck board between gaps on top of joists, and it'll start burning both directions. But in this case, we're burning towards the home, and it will get to the home as a small fire. Fires that get big in a deck they start getting big in the underdeck area, as we see on the far right. So things that, we'll get to some of these strategies to fix this. This just shows you that it doesn't necessarily need to be a big fire that gets to the home. And then once it gets to the home, if there's combustible siding there, it can ignite that and the fire will get bigger. This is a report that was just issued by IBHS by a colleague and myself, colleague at IBHS and myself. And this just points to the importance of the underlying joist should they ignite. So this is another reason why you really want to avoid flames impinging on the underside of the deck. So things you can do that minimizes the chance of flames getting to the deck from the underside, you should make all effort to do that. Not in this report, but something that my colleague discovered was the importance of the joist itself. And if you use a non-combustible joist, even with combustible deck boards, that deck performs much better. The first cost of metal joists are definitely higher than a wood joist, and so to avoid that, you really need to do what you can to stop embers, to stop flames from getting in that underdeck area. Here's that picture here's a picture of what I talked about earlier. You can replace the deck board immediately next to the building with this with a non-combustible option, whether it be a deck board or a metal grate, for example. And then here's just using metal flashing to have this non-combustible vertical and horizontal zone right at the deck. And you need to, again, make sure that you tuck in or let in the flashing, in this case at a lap joint, so that water coming down won't get between the deck, the siding and the flashing. Here's another option, make your deck board gap as big as possible. That's good for minimizing propagation of flame that might start in this between deck board gap. And then if you're using a wooden joist, using a metal flashing cap, or in this case, metal foil face bitumen tape. This in essence takes the joist out of the picture and makes it harder for ignited decks to propagate, to sustain flaming and propagate outward. So these are a couple of options when you're having a new deck, or when if you want to just retrofit by taking a deck board or two next to the house, then you can add this at the same time. And here's a friend of mine that is retrofitting his deck, and he put these metal pieces on the top of the deck. When you on the top of the joist, when you put the deck board down, that metal piece stays pretty stays put. And he used a metal grate right next to the home. And this is much easier to do when you have deck boards that are parallel to the deck, to the home. When deck boards are perpendicular to the home, it is, as you see here, it'd be a more of a challenge. You have to sort of work with the underlying support system to be able to cut those deck boards and have them be able to rest on something and have the metal deck board be able to be supported also. So more of a challenge if the deck boards are perpendicular. A lot of people have questions about deck enclosures. I'm not a huge fan of deck enclosures because they can have sort of moisture degradation implications. Here we have, particularly when you have a deck board deck, and if you have a solid surface deck, lightweight concrete, something like that, enclosing the underside can make perfect sense. But if you have using deck boards, you're just asking for trouble from a moisture perspective, because water that gets in can't get out. You can have moisture degradation issues, decay of joist members, corrosion of fasteners, hangers, and the like. So, when you have a horizontal enclosure, you need to make sure you have a solid surface deck going along with it. And if you have a deck that is close to the ground, then using screening is I think, perfectly fine. It keeps debris out and keeps embers out at the same time from that direction. But as we said before, you can have embers entering through the deck, between deck board gaps. So be careful with with enclosures in general, and should you have them, just make sure there's a way for that under deck area to be able to breathe, so that you don't have moisture problems along the way. Because I can pretty much guarantee you that the house will be rained on before it sees a wildfire. Decks overhanging slopes, this is one area where you might have a solid surface deck and a horizontal enclosure, just because of the potential for flames to get there. If you have a tree, this is from Waldo Canyon fire, Colorado Springs, where these trees crowned, ignited, burned 5 houses that were atop of the slope here. So trees, your only option is to thin them enough that you don't crown burning up slope. If you have chaparral, if you're in California or other places where you have chaparral or grassland, you could help by putting a retaining wall, a non-combustible retaining wall downslope, so the fire burning upslope will sort of be deflected by that retaining wall, helping to protect the deck and the home. But with a forested or wooded situation, really you need to be worrying about thinning the trees so that the crowning doesn't occur. Oh, sorry, I forgot about this. So garages, detached or attached, really remember defensible space applies to them, and you want to make sure that the garage doors are well sealed, and the pedestrian doors are well sealed so that embers can't get in so readily. We all store stuff in our garage, similar to an attic space. One thing you can do to see how leaky, so to speak, it might be is you can either during the nighttime, you stand outside the garage, turn on the lights in the garage and look for the light patches, or during the day, turn off the lights in the garage and make it as dark as possible, and then look for light coming in. This is not a garage, but you can sort of see the point here. Where the light is embers can certainly enter in those spaces, and you can take precautions to do a better job sealing in those areas. So I finish up on fencing. I think if it's attached to the house, treat it as a house. So fencing, just in general, you want to have a non-combustible part where it connects to the house. 5 to 8 feet is a good number. This experiment we did at IBHS pretty well showed that this thing called what I call a privacy fence, where all the planks are on one side, it's much more easy for that to ignite by an ember exposure. If you have a lattice fence or a good neighbor fence where the planks alternate, these are more porous, so harder for embers to land in any one spot and harder to ignite. The one thing that was also clear, though, is that if you have debris at the base of the fence, that will ignite first, and that is where the most easy way for fire to burn to the building, and it'll get there as a backing fire because wind is sort of blowing away from the home at this point because of the way that wind does when it hits a building, and it sort of recirculates backwards. So from a guidance perspective, we want to keep debris away from the fence, do that on a regular basis. If you're designing this for a home, then you want to put a non-combustible section near the home, and then just tell the homeowner, don't do this. It'll just make things worse for you and your fence. So here's this non-combustible part. So you have plank fence, fine. It will ignite potentially. You don't want it to do a number on your home. So you want to make sure that it cannot burn to the home and you do that by installing this metal, in this case, metal part. Okay, I think that's it. We can go to our next session of questions, I think, if there are any more. I really appreciate your attention and for staying with me for this time. I think I'm going to stop sharing my, should I start sharing, stop sharing? Or do you want me to keep it on for a minute?
You could keep it on while we ask just this next question, and then we'll go ahead and move on to our conclusion and then the general Q&A.
Okay. Okay.
All right, that was so informative. Thank you so much, Steve. We have one more question here that we have time for that's related to attachments. So can you talk some more about flammability of composite decking material? Are there some products that are better than others?
Good, thank you. So I think the way that I answer this question is twofold. One is, do you only need to worry about embers? Have you done a really good job of creating this non-combustible zone or nearly so underneath the deck so that you don't have to worry about flames touching the deck? If that's the case, you only need to worry about embers. And our research showed that the higher density decking materials, this includes all plastic composite decking materials and higher density wood decking products such as epay and other tropical hardwoods. These are far more resistant to ignition by embers than, say, redwood and cedar, which are more vulnerable, by a stretch to ember ignition. So if you only need to worry about embers, then higher density products, and you're building a new deck, then higher density products are the way to go. If you have an existing redwood deck or cedar deck, these are more vulnerable to ember ignition. And in these situations, that's when you want to really consider replacing the deck board near the home, so that with a non-combustible option, so that should it ignite and burn to the building, it'll have, or burn to your home, it'll have a non-combustible thing in the way, so it won't be able to get there. And also, even though we know that embers can ignite deck boards without debris between the deck board joists, between the gaps, if you sort of routinely remove that debris, it'll make it easier or harder for this ignition to occur. So, and if you have to worry about underdeck flames, some plastic composites can definitely be more vulnerable to that kind of exposure. I would encourage you to look at the State Fire Marshal's building materials listing website again, and this case, enter decking products in the category. The compliance measure, or the path for compliance for combustible deck boards that all decking products use, all combustible decking products use, is an underdeck flame impingement procedure, and so test, and so those are the ones that would meet this particular criteria. I would say though that your best bet for all of these kind of decking products is to have a condition under the deck and on your property that really minimizes the chance that flames can get to that underdeck area. There's just so many things that can go wrong when flames impinge on the underdeck area, because they're also impinging on the siding under that deck area. Whatever you can do to make that far less likely is really the best path forward for you.
Great. Thank you so much, Steve. That was super, super informative. I'm going to go ahead and share my screen really quick to go through some concluding thoughts here before we start just our general Q&A section. So I'm just going to go over this really briefly. These are just some resources on how you can learn more. Steve's presentation was, oops, sorry, something just popping up. Steve's presentation was so informative. So, but if you want to learn a little more, these are some resources. Again, we will be sending these out in our follow-up email with links to each of them so that you can learn a bit more. And then we recommend getting involved. So there are so many organizations that you can get involved with that work with wildfire preparedness and specifically home hardening. So look for your local networks like us, the Tahoe Network of Fire Adapted Communities. There's also the Nevada Network of Fire Adapted Communities. Keep an eye out with your university cooperative extension programs. So you have both University of California Cooperative Extension, the University of Nevada, Reno Extension, and I'm sure other universities have extension programs as well that you can get involved with. You can also get in contact with your local fire district. A lot of fire districts work on this type of stuff, and it's always great to be involved with them. Resource conservation districts as well. So resource conservation districts are all across the country, and specifically in the West, they do often have programs that deal with wildfire. So look at their website, reach out. And then, of course, FireWise USA through the National Fire Protection Association. For those of you who don't know what FireWise is, it is a national program that encourages neighborhoods to work together to prepare for wildfire, and it establishes a recognition system for neighborhoods that do. So as building professionals, you can play a pretty big role in that. So check to see if your neighborhood is applying for FireWise or a neighborhood near you, and stay in the loop with that. And then, of course, fire safe councils. So there are fire safe councils all across the state. You can see if there's one in your county or your region. And of course, there's the General California Fire Safe Council as well. So these are all good places to get involved. And so before we go into our general Q&A question, we have some last questions for you. So I'm going to launch a third poll here. So we just want to know now, after hearing that presentation, how likely are you to recommend and implement home hardening techniques? Very likely, somewhat likely, not likely, and which retrofits do you think you're most likely to recommend and implement? I'll give you about a minute here. All right, it looks like we got some good results coming in. All right, maybe about 20 more seconds. If they're still voting. All right, I'm going to end it there. Let's see. So this is super awesome. It looks like about 93% of attendees are very likely to recommend and implement home hardening techniques. This is great to see, especially after such a significant wildfire season. In terms of which retrofits folks are most likely to recommend and implement, we got a lot of people recommending upgrading vents, all of the above, which is great to see. As Steve mentioned, these all play a role. So this is super, super awesome stuff. And I know you guys have a ton of questions, so let's get a little more into that. We have a couple unanswered ones here. So Steve, these are for you. What product is the metal joist flashing?
So the metal, so you can go two different ways here. One is just to use aluminum flashing that comes in 4-inch wide strips. You have to sort of bend it to fit. The foil phase bitumen, if you're referring to that one, that is just regular flashing that you would get in the lumberyard, at your lumberyard or hardware store. the foil face part is really critical to have. And because of the bitumen part, if you can't really be pretty confident about no flames under the deck, then that's probably not your best option. Your aluminum that you would just sort of bend over the top of the joist and down would be your best option. But that would just be again regular flashing. It comes in like 4 or 6 inch strips and in a roll. So you just unroll it, and you can actually get flat ones in a package. So if you just walk to your, not walk, but if you go to your lumber yard, your local lumber yard, or your local hardware store, they're likely to have it. Both of them.
Great. Thanks, Steve. What systems can be designed into new construction to better protect a new home in a fire? Has anyone come up with an exterior fire suppression system, possibly including standby power, pumps, sprinklers, alternate water supply, body of water, etc.? Defensible space and the WUI features may not be enough in a wind-driven fire event.
Yes, so there definitely are a lot of vendors for exterior sprinkler systems out there. I created sort of a, personally, obviously, because of my interest, I have a spreadsheet, and I have, there's sort of all service kinds, and then there's groups that will sell you the sprinkler that you can put on your roof, for example, and turn it on when wildfire threatens. I think some of the points that you made are really critical. If you're going to go this route, you don't really want to hook up to municipal power, because you're going to, if everybody does that, then there won't be any water for the first responder firefighters. So you want to have a standalone water source, and you want to make sure you have a standalone power supply, just because you know, the power will likely go out. And I think it's also important to acknowledge what you already did with the wind part, is that during high wind events, the water may not go exactly where you think it's going to go, because the wind will push it also. So and there's a number of places you can put these sprinklers: on top of the roof, under the eave, out on the property, and point them towards the house. Depending on the vendor that you might choose, you know, they're going to put them one or all places, depending on who you pick. And then you have to worry about how you're going to turn the thing on. And if it's up to you to turn it on, or, you know, they have some automatic turn on systems. There's a lot to consider. If you're thinking of doing this, I would have a chat with your local fire department, because they'll likely have some more pertinent local guidance for you. And I think if you want to send me an email, I'll send you my spreadsheet. And I only was looking at these sort of all service vendors that you know, come install. They have a turn on system. Some of them have systems that incorporate phone, but you know, so there is a lot to consider. And I should say that there are a lot of anecdotal evidence of them working, but there's very little third-party research that provides guidance as best places to put them, how to address high wind event kind of distribution issues. There's still a lot unknown about these kind of systems.
Great, that is super helpful. Thank you, Steve. Next one, I keep hearing that redwood is resistant to fires. I'm having a hard time believing this is true to the extent of building with it: siding, fences, decks, and particularly entry steps. Please address.
So I think the redwood being resistant to fire may be pertinent to sort of wildland fire issues. It has pretty thick bark, so the tree can be protected. Wood is combustible. I mean, I think you have to sort of acknowledge that. And our research showed that redwood decking in particular is the most vulnerable to ember ignitions. So that would apply to a step also. But I would also say that there are certain times when you don't need to worry as much about the material itself. And it's when you only have to worry about embers, it's more about how things are put together, with the exception of the redwood deck. But even there, if you have if you can address the joist issue, and if you can have deck board gaps of 1/4 inch or so, which is wider than normal, then it becomes less vulnerable. And particularly if you have this non-combustible zone right next to the house with the metal deck board or the metal grate. If you really want a redwood deck, there are things you can do, but you need to make sure that flame impingement and extended radiant heat aren't part of the equation. So it's a walk around, but I hear what you're saying. And it is definitely a combustible material and has its vulnerabilities. That's just, depending on the particular component, there are things you can do to minimize the potential damage, but these require maybe more effort in terms of vegetation management and location and other things to preclude the chance that flames touch it and radiant heat is exposed to it.
Great, thanks, Steve. Next question, how do you evaluate the importance of neighborhood fire mitigation versus local house measures? It feels like the neighborhood measures are really important.
I agree. When you're in a neighborhood, it's really important to have neighborhood buy-in and to have all neighbors on a similar page, just because any one neighbor can do quite a number on the neighboring properties. I think I like to say, and I think once I say this, you'll hopefully agree, that the fires that most people remember, I think wildfire researchers maybe remember a lot of fires, who knows, for whatever reason, but the general public, the fires that they remember are the fires that happen in a famous place. So the Rim Fire in Yosemite, the Yellowstone Fire in 1988 in Yellowstone National Park, famous places. The other kind of fires that people tend to remember are the fires where a lot of homes are lost. And when a lot of homes are lost, inevitably, it's a lot of home-to-home fire spread. And that just points directly to the need for a neighborhood involvement in terms of making the neighborhood more resistant to ember kind of exposures, because neighbors that aren't prepared, their houses can have an influence on a lot of other houses. So I agree with you. Neighborhood involvement is really critical in this effort.
Yeah, that's a really good point. Thanks, Steve. So we're running out of time here, so we'll just do one more question. For the coffee park discussion, closely spaced homes igniting makes sense. Why do you think some research is showing that more rural homes are at a greater risk than ones in neighborhoods like this?
So I think there's some argument for protecting more densely packed neighborhoods. I guess I'm not bought in on this one. I think even if you have a densely packed neighborhood, or you design a community that way, you need to make sure that community can resist ember exposures, and it has to be ember ignition resistant. Otherwise, because of the proximity, ignitions of one will do what happened in Coffee Park. It'll result in a lot of other ignitions via building to building scenarios. I think, and I don't agree with that sort of premise to begin with. So.
All right, thanks, Steve. So we are just about out of time. I want to give a huge thank you to Steve for his time and expertise. I learned a lot from that presentation, and so I hope everyone got a lot out of it. Thank you again, everyone, for attending. Like I mentioned earlier, we will be sending a follow-up email answering the questions, and also there will be a form in there if you have additional questions that didn't get asked during the presentation. There will also be a link to watch the presentation again on YouTube if you missed something or if you wanted to send it to one of your peers. And there will also be information on how to opt in to receive the Wildfire Home Retrofit Guide that will be published at the end of the year. So thanks again, everyone, and it's been a pleasure.
Thank
and
you. I want to say
everyone has
too.
a great end of the night.
Yeah, thanks for me. Thanks for joining.